This is sections 3.5 and 3.6. I do teach them together. The homework is put together as well. Okay. Introduction to relations and functions, and then function notation and linear functions. Okay. We need some definitions first, and then all of this will make a lot more sense once we get into some examples. Okay. A relation is any set of ordered pairs. So I could list a bunch of ordered pairs and it would be a relation. I can put any kind of squiggle I want to on a graph and it's a set of ordered pairs, so it's a relation. This is a very general definition. Okay, now a function is a relation in which for each value of the first component, for each x value, there is exactly one y value, okay? This will make a lot more sense in a minute. We need a couple more definitions before we can start explaining this, okay? Domain is all legal values of x. Now, in this class, there are two things we have to worry about. We cannot divide by 0, okay? So I can't plug in a number that gives me a 0 in a denominator. So that would not be in the domain. And we cannot take an even root of a negative number. So I can't talk about square root of -1 until much later in this class, or the square root of -4. Now, what does it mean by an even root? I can't take a fourth root of -8 either. If this number, which is called the index, which we get into much more detail later in the course, you won't be able to do that, okay? Now, range. Range is all possible values of y. We haven't used this word yet, but we have talked about range. When we were talking about the special cases of the absolute value problems back in the last chapter, we talked about how no matter what number you plugged into the absolute value, once you calculated the absolute value, you would get a positive answer or 0. So we were talking about the range. We were talking about the possible answers you could get. Okay, the unofficial Maggie's silly blob definition of a function. I'm going to use a silly story to draw a picture, and then once you have the picture, the idea of what a function is will make more sense, okay? So I want you to draw of yourself two pretty blobs, because we are all capable of drawing blobs. Okay, now these blobs represent armies at war, okay? So this guy has a cannon. This is the biggest, baddest piece of artillery we have. We have cannons, okay? We take a cannon and he fires and he hits this target over here. That makes sense, okay? Now this guy has a cannon as well, and he fires and he hits this target, okay? Still making sense. Now this is a really important target, and this guy did not take it out completely. So this guy aims the cannon and he hits that same target again. All of this is making sense. Okay, now this guy, he fires the cannon and the cannonball splits into two pieces and takes out two targets. The Roadrunner is not standing here. This was not fired by Wile E. Coyote. Nothing was manufactured by Acme. Cannonballs don't usually split into two pieces. This is not allowed in a function. Okay, so we've just drawn a picture. It's a silly story. Now, how does this relate to math? If this blob is our domain, which means it's our x values, here we plugged in one x value and we shot it off, and this is our range, which are our y values. Okay, so fired this x goes to this y. That makes sense. I can plug in two different x values and get the same answer, and that's still okay. But I cannot plug in one number and get two answers. This is what's not allowed for a function. The way this shows up a lot of times is a repeated x value. So for example, let's say that this x value is a 1, and then this is a 2, and this is a 3. Your ordered pairs in this sample would look like 1, 2, and then 1, 3. And you can see that that would give you a repeated x value. Whereas here, if this is 4 and 5, and this is 6, your two ordered pairs would be 4, 6, and then 5, 6. Repeated y values are okay. Repeated x values are not okay. Okay. So, first type of problem is the relation a function and then give the domain and range. Okay, like I said here, we can't have repeated x values. Repeated y values are okay. To find the domain, all you have to do is to list all the x's and put them in braces. To find the range, you list the y values in braces. That's it. Okay? So this is our first relation, 8, 0, 5, 4, 9, 3, 3, 4. We're looking for repeated x values. 8, 5, 9, 3. No repeated x values. This is a function because there's no repeated x values. Fn is a very common abbreviation for function. Okay, so we know it is a function. Let's find the domain. The domain, you list your x values. 8, 5, 9, 3, close. They don't have to be in any particular order, just list them. Now your range, you do the same thing, but you list your y values. 0, 4, 3, and a 4 is repeated, but that's okay because it's the y value. So it is a function because there are no repeated x's. The domain, we list our x values. The range, we list our y values. These really are this easy. Okay, don't make them hard. What about this one? 9, -2, -3, 5, 9, 1. I have a 9 in my x here and here, so this is not a function. Okay, so I need to give the domain. It's going to be 9 and -3. I don't list the 9 again. The range is -2, 5, and 1. Okay, so if you have a list of ordered pairs, all you have to do is look for a repeated x value. Okay, sometimes though, like I said, a relation can be a list of ordered pairs, which is what we have here, or it can be a squiggle on a graph. Now, if you have a graph, you can't possibly list every single ordered pair and check to see if you have repeated x values. So we have to use a different trick. Okay, what we're going to do is called the vertical line test. What you do is you imagine a vertical line sliding through your graph. If that vertical line ever hits your graph more than one time, it is not a function. So imagine a vertical line coming through here, and you can slide it. A lot of people call this the pencil test, using a pencil instead. It gets pretty steep over here, but it still never hits more than once. If it never hits more than once, it is a function. However, like right here, you're doing okay, and then as soon as you hit this area, it doubles back on itself, and the vertical line hits more than once. This is not a function. If you were to try to, if this were on a grid and you could read off your points, this point, and this point would all have the same x value. And we know that's one of the things that's not allowed for a function. Okay, so let's look at this graph right here. We want to know, is it a function? And then we want to give the domain and range. Okay, is it a function? Does it pass a vertical line test? I pass through this, and I hit more than once most of the time, right? So this is not a function. Okay, now for the domain and range. Over here, we had finite number of points. We only had 4, so we could list them. Here we only had 3 points, so we could list them. When you have a graph, every single point in here is listed. We cannot list infinite points, so we have to use interval notation, okay? Now, the way you want to think about this is if you were having to give directions to somebody, like where can you find my graph on this particular thing? What you want to do for domain is you want to figure out like where it is in relation to the x-axis. Every single bit of my graph is between here and here, right? So this would be 1, 2, 3, -3, comma, 5 in brackets because it exists at this point, okay? So this is where on the x value, x-axis. Where can I locate it? I can locate my graph between -3 and 5 on my x-axis. Now for the range, it's the same thing but with y, okay? Where is this on my y-axis? My whole graph is between here and here, which would be at -2, and that is at 3. Now we have a tendency to put the top number and then the bottom number, but these need to be in numerical order. So you definitely want to put -2, 3. And this is where on the y.